Okay. So in our previous lab, I think we have gone through some setting on IP addressing, right? But we haven't covered that in the lecture session. So what we want to do today is that we want to go in depth about the IP addressing, okay, specifically in IPv4, okay, and eventually we will look into IPv6 also. Okay, so basically what you have gone through in the lab is that you have gone through in the practical manner, but theoretical manner we will cover during this session, right? So we will look into IPv4, okay, is IP protocol version 4, okay, and we also have IPv6, okay, which is currently by default at this moment will be shipped. Any devices that we ship basically will be through or using IPv6, okay, but it also have the IPv4 setting that we configured, okay. So and then we would like to see how the error messages can be managed or controlled in the network layer. Okay, so now we are on the third layer. Data link is on the second layer. Physical is on the first layer. So we are currently looking at the third layer, right? So for today's outcome, basically we would like to know more about IPv4. Okay. Then we want to know about this ARP, Address Resolution Protocol. Okay, and also we wanted to see how does error reporting mechanism in the Internet Control Message Protocol, shortly known as ICMP, right? And then we want to describe the concept of multicast and how do you manage multicast in IGMP. Okay, so we will see that in networking we have what we call unicast, okay, that managing connection between one-to-one. Then we have the multicast, okay, and we have the broadcast. Okay, so broadcast is one to all. Multicast would be one to selective group of users. Okay, and then we want to look at IPv6. Okay, so these are the things that we will cover for today's session, right? We will also cover a sub category of IP addressing that we call classful addressing. Then we go through classless addressing, and eventually you can also have what we call static management of IP and also dynamic management of IP, which not be covered by this slide, but I have tried to give you an impulse what does it mean. Okay? So we can also see on the network address translation, okay, where we see that when you have a network, okay, within your organization, basically that one we use what we call internal network addressing, okay, and then we have few IP addresses that can be seen by the outsiders, okay, but internally you are currently using what we call your private IP addressing. So how do you get the PC or your devices to be connected to outside? Okay, you have to go through what we call network address translation. Okay, so you will map your internal address with your outside address, okay, so that you can communicate between each other end to end. Okay, and then we will look into the mapping, okay, between logical and physical, okay, which is called ARP, Address Resolution Protocol, which you guys also have done that in the lab. Okay, and then we also want to know what is DHCP, physical to logical address mapping. Okay, this one basically you guys have been using it for the whole time, okay, without knowing it. Okay, what does this DHCP represent is that you are giving an IP address without whenever that you enter any network, okay, dynamically or basically automatically lah. Okay, you don't have to configure it. Okay, so that is where you have your DHCP, okay, Dynamic Host Configuration Protocol. Okay, so that you will be able to connect to your network, which currently is the MMU network. Okay, and you can access the internet, access file from the internal server and so forth. Okay, and then we will also we also look into ICMP, IGMP, and finally IPv6 addressing and structure. Okay, so These are the things that we will cover for today. Okay, but largely we will see on the IP before how it is being implemented. Okay, to start with IPv4, you will see that we have what we call 4 octets of addressing, right? Okay, so you have these 4 octets. Usually, it will give you something like when we use in lab 1. I haven't changed this. Right. Okay, so you will see that the address that we use would be something like 1. One, one, one. I did numbers. Okay, so you will have something like 192.168.0.1. So basically, what we can see that this is what we call the first octet. This is the second octet. This is the third octet, and this is the fourth octet. Okay, so this is in decimal. In binary, usually, perhaps you will have some binary number 8 of it. Okay? So you have say that all 1. So you have 1, 1, 1, 4, 5, 6, 7, 8 dot 1, 1, 1, 1, 1, 2, 3, 4. Okay. 1, 1, 1, 1, 1, 1, 2, 3, 4, and finally 1, 1, 1, 1, 1, 1, 1, 1, 1. So basically now you have all this in 8 bits. Okay? So a single octet over here represents in 8 bits, okay? And this one can be up to 255. Okay? So that's why then when you see the address like 255.255.255.255. Okay, so these are the maximum numbers of that this binary bit can represent, because with 8 binary bit, so you have the maximum here is 2 to the power of 7, okay, plus 2 to the power of 6 plus 2 to the power of 5 until plus 2 to the power of 0. Okay, so this is all the 8 bits. Okay, and if you sum it up, you will see that it comes to 255. Okay, so that is the basic thing about this IP addressing in 4 octets. Okay, so you have 32 bits. So 8 times by 4, you have 32. Yeah, 8 kali 4 is 32. So you have 32 bits, okay, of address that unique and universally define the connection of the device. Okay, and this is what we call IPv4 addressing. Compared to IPv6, we have 1 to 8 bits. Okay, so we'll see that later. Other than that, okay, so with respect to this address, okay, if you have, because you have the 32 bits long, so if you do the 2 to the power of 32, basically you have this 4,204,967,296 IP addresses. It looks a lot, but actually it's not enough for the whole network itself, or the whole world. Okay? So that is why IPv4 is currently being replaced by IPv6. Okay? So this is the one that I've already showed you. Then it can be either be represented in binary numbers, or you can represent it at dotted decimal, okay? Or perhaps you can represent it in hexadecimal. This is very rare. Usually in our conversation, we either talk this in a binary or dotted decimal. The hexadecimal basically will see that in IPv6 later. Okay? So this is the binary numbers that represent the dotted decimal. So if you are in the exam and you have the calculator, so you can just change this, say that 1 to 8, okay, change it to decimal, you will get this value. Okay, from decimal to binary. Okay? 11, you will see that this is the representation in binary, 3, and also 31. Okay? So you have to do that based on the octet that you have, right? Okay. So perhaps this is an example. If you want, if they ask you how that you can convert it into dotted decimal. Okay. So basically, what you need to do is that you have to change or you have to find out what is this octet. Okay. So say that this octet is 129. Okay. Then the second octet is 11. So you have 11 over here. The third octet is also 11. So you put 11 over here. And lastly, you have a 239. Okay. So in decimal, you will represent it 129.11.11.239. Okay. Same goes for here. So this one will represent these specific numbers. Okay. The second octet will represent this number, and the third octet will represent this number, and finally you have the last octet represent this number. Okay, and you can see that as mentioned just now, if you have all ones, your octet will become 255. This is the maximum number, right? The least number is when you have all zeros. Okay, so you have all zero, meaning that this octet will be 0. Okay? If you have all 0. Okay? So that is on the changing from the decimal from your binary to your dotted decimal, and you can also do the same thing lah, okay, from the decimal to the binary number. Okay, so you have to focus on the dotted one, okay, and it represent one octet. Okay, so that is on the conversion. Okay, coming to the next concept is that in IPv4, since you need to manage the network properly, okay, so what they represent is that we can divide it into two different segments. Okay, the first segment is what we call the network segment. Okay, and the other one is the host segment. Okay, so you will see that out of the 32 bits itself, okay, so you have what we call the network bits, okay, and also your host bit. Okay, so sometimes this is also called network bit. And also this is called host bit. Yeah? It should be within the same 32 bits. Okay? If you sum the number of n bits, which is network bit, plus the number of your host bit, it will become 32. Okay? Say that later we will see that you have what we call class A, okay? Which the network bit is equals to 8. And the host bit is equals to 24. Okay. And class B, later on, you will see that the network bit is 16 and the host bit is 16 also. And that class C, later on, you will see that this is 24 and the network bit is 8. Okay. So this is the number of bit. Okay. If you want to know what is the number of hosts, for instance, over here, so you have to do the 2 to the power of the host. Okay, so 2 to the power of 8 over here, I think you will get 256 number of hosts altogether, right? So for here is 2 to the power of 16, 2 to the power of 16, and for this one is 2 to the power of 24, right? So with respect to that, say that in later exercise where you will ask, can you generate a network that can cover 200 numbers of network or hosts? Okay? So basically, you will need to see this. Okay? So if you use 8-bit for your host, okay, so you can go up to 256 numbers. Okay, which is within the 200 network. Okay. If you want to go more than 256, say 500, perhaps you can use the 216 or perhaps the 2 to the power of 24. Right. So this is a dynamic segment where you have the network address or the network bits and the host bit that sum up to become 30. Right. Any question? Oh, no. All right. Move on. Right. As mentioned just now, okay, even if you go to the next slide, you will see that this is how the segment or the classes of your IP addresses. So you have this, where you have actually 5 classes, okay, but the one that usually we mention is class A to class C. Okay, so you have your class A, class B, class C, and this is considered as the network part. Okay, the blue one, this one for class A, which is 8 bits altogether. For class B, you have these two be combined together, so that is you have the 16 bits using here. This one only 8 bits. Sorry, this is 16 bit. This is 8 bit, and this is 24 bits altogether, right? So this is for the network, and for the host address, you can use all the 24 bits for class A. So you have 24 over here, and you can have 16 bits that represent your host, okay? And finally here you have only 8 bits to represent it, right? And then you have the class C, okay? That we call it multicast address, and the class E reserved for future use, okay? Which being represented. Okay, so how do you identify which is which? Okay? So class A, basically it will start with the number of 0. Say that if you have a 0, 1, 1, 1, 1, 1, 1, 1, okay? Or 0, 0, 1, 1, 1, 1, 1, okay? Or 0, 1, 0, 1, 0, 1, 0, 1, okay? So when you have the most significant bits of the first octet over here, right? Start from 0, so it's actually class A. So anything that start from 0 is a class A. Okay? Anything that start with 1, 0, okay? So it will be a class B, and anything start with 1, 1, 0, it will become class C, right? So this is how you identify it. Okay? So with respect to this, okay, so what we can see is that for A, okay, you have the number of bits that being used for your network is 8 bit, as mentioned just now. Okay? The blue one represents the 8 bits. The green, the orange one here represents the 16 bit, and the brown one here represents the 24 bits. Okay? And since you can use from 0, 0, 0, okay, up to for the network here. So basically, you can start for network A. You can start from 0, 0, 0, 0, 0, 0, 0, 0, up to 0, 1, 1, 1, 1, 1, 1, 1. So basically, you can go, or your byte can go from the first byte can go from 0 to 127. Okay, so if you see that the 1111 here is can go up to 127 itself, right? And here the next, okay, for the class B itself, it start from 1, 0, 0, 0, 0, 0, 0, 0, up to 1, 0, 1, 1, 1, 1, 1, 1. So basically, you can see that the range will start from 1 to 8. Right, is my mouse. So it starts from this 1 to 8 until 191. Okay, and then the next one will start from 110, 0, 1, 0, 0, 0, 0 until 110, 1, 1, 1, 1, 1. So here you can see that it will go from 192 to 223, right? So that is why sometimes when you see that for class A, you will say that it start from 0, okay, 0.0.0.0.0, or sometimes you use the 10.0.0.0. Okay, so this is a class A because the first octet here is within this first byte. Even if you have 126.0.0.0, okay, this is actually class A. Then If you go to class B, you will start with 128, 128.0.0.0 until 191. Okay? And class C, the one that we usually use, that I use for my example, is 192. Okay? So I will usually use the 192.168.0.0 or 192.168.1.0. These are the common IP addresses that we use on your routers. Okay? Then you also have the D, okay? That range between 224 to 239, and the last is 240 and 155. Okay? So basically, if you are given in a binary number, and then the first octet start from 0, okay? So you can say this is a class A. If it's 10, then class B. If it's 110, it's class C. Okay? Also, you can identify if it's within in decimal 0 to 127, this is class A. 128 to 191 is class B. 192 to 223 is class C. Okay? So, and on top here, you can see that the amount of address that being covered, okay? For class A, you actually up to 50% of the total addresses. Then class B, 25%, class C, 12.5%. Then you have the 6.25% for the D and E. Okay? Okay, coming back to the one slide before that. Okay, so with respect to the different classes that I've already mentioned just now. Okay, so you can see that you can have the number of blocks, okay, the block size, and the application that you can use for it. Okay. So with respect to that, this is what we call class pool addressing, okay, where the address space is divided into 5 classes, which is A, B, C, D, and E. And in class pool address, a large part of the available address were wasted. Okay. What does it mean? It means that although you wanted to have just 3 number of users, or perhaps 20, or perhaps 100, but the minimum that you have to use for class that you can use is class C is 256. So meaning that the rest of the network, which is if you wanted to cover 100 network, 100 hosts only, so you have to use 256 minus by 100. That is the wasteful number of user, is 156. Okay? So this is the maximum number of user if you wanted to use class C. So you have to stick with this number, okay, if you want to use this what we call class pool. Okay? So this is a class pool addressing. Same goes for class B. Okay? Basically, although you wanted to have 5,000 number, or you wanted to have 10,000 numbers, okay, of course, okay, but you have to use this 65 because you cannot use class C. You have to go to the next level, which is the class B, so 65,000. So whatever the numbers that you want to use, you minus by this, it's the wasteful number of hosts. Same goes for here, and you will see that much number of hosts that is not or wasteful is being increased if you go more further up. Okay? So to solve this, later we'll see that we have what we call classless. Okay? And then also we can see that how you can use the subnetting to further improve how we can manage the network with a smaller number of users. Any questions so far? Right, so here it mentioned, you can see that the class pool addressing, which is almost obsolete, okay, and it is replaced by classless addressing. Okay, so the class pool, where you have to either use either class A, B, or C, is not very useful, okay, for a very small number of organization. So we tend to use what we call classless addressing. Okay, so for instance here, okay, if this is being given to your small organization, say that you are given this whereby you have the 205.16.37.32 until 205.16.37.47. Okay? So you have the same binary, which is actually 16 addresses over here. Okay? So this is the first, this is the last. Okay? So later when we talk about subnetting, okay, so we need to identify basically 7 things that we need to identify. I can't list down all this together right now, but basically you need to know what is the network IP. Okay? You need to know what is the broadcast IP. You need to know what is the first host IP. Okay, it's not the same as the network ID. You need to know what is the last host IP. Okay, then you need to know what is the next network IP. Okay, 6. Then you need to know what is the number of IP addresses that it can convey. And last but not least, what is the CIDR or the subnetting that you are using? Okay, so that one we'll see on data. Okay, but within that, usually, okay, if is this is one subnetting, the first address will be the network address, and the last will be the broadcast address. Okay, then out of this, say that out of 16, basically you have to neglect or you have to subtract 2 addresses, okay, which is the broadcast and the host ID. So the useful addresses over here, for instance, will be 14 rather than 16. So you have the whole chunk of 16 addresses, but basically you can use for your host only 14. Okay, so in IPv4 addressing, a block of address can be defined as XYZT/N, in which XYZT define one of the addresses and N define the masks. Okay, so for class A, basically, so this is for class A. So for class A, basically the mask will be 255.0.0.0, okay, because you are using the whole byte here for your class A. For class B, you will have 255.255.0.0, and class C, you will have 255.255.255.0. And the subnetting, usually we define this as what would be the net mask. This one will be /8. This one will be /16, and this one will be /24. Okay, how do you get this? Actually, how many bits that you are using for here? Okay, so for this one, you actually 255 means that you use the whole 8 bits for your class A. Okay, so this one is actually the number of bits that being used for your network. Okay, so here you have 8. So for class B, you have 8 plus 8. So you have 16. Class C, you have 8, 8, 8. So you have 24. Okay. So for class A, B, and C, this would be the masking that represent it. Okay. And the first address in the block can be found by setting the rightmost 32 minus n bits to 0. Okay. So basically over here, what it meant is that for class A, so if you are using the n bits over here is 8, okay, so 32 minus 8 is actually 24. So you have to have 24 zeros. Okay. So if it's a class A, so now you have 1, 1, 1, 4, 5, 6, 7, 8 dot 0, 0, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0. Okay, so basically here, the total 0 over here is 24. Okay, so that's what it means over here. The first address in the block can be found by setting the rightmost 32 by n bits to 0. Okay, so if you want to know what is this host address, okay, so you have to turn this mask to 0. Okay. Right. So then, example here, a block of address is granted a small organization. Okay, we know that one of the address is 205.16.37.39/28. What is the first address in the block? Okay. So what you can do first of all is that you can see what is the mask 28. Okay. So what is the number of bits that can be used? Okay. So now if you already have this 28, for your network address. Okay, so you have this 28. Okay, and what would be this? Okay, so 32 number of bit minus by 28, you will get 4, right? Okay, you will get 4 over here, right? So you are actually using that from here. Okay, so you are using the 4 here. Okay, is actually the host address. Okay, so you are using 4 over here. So if the binary representation of the given address, which is the 205, 16, 37, 39, okay, so so if we do this, 32 minus by 28, the right host to be 0. So we change this bits into 0, okay, because this is just one of the range. Okay, so you will have this is the first address, which is the network address. Okay, so you will get, if you use your calculator back, so you will get the 205, 16, 37.32. Okay, so now the 32, okay, is the network address. Okay, so this is the, by simply subtracting whatever the pass over here, okay, with the 32 bits of the total bits that we use for your IPv4, you can get what is the network address. Okay, so this is how it's being done. Okay, so here it says that the last address of the block can be found by setting the right host 32 bits to 1. Okay, so the next thing is that the same question. Okay, but now you want to know what is the broadcast address. Okay, so what you can see is that the 4 bits that you have just now, so you change to 1, okay, and you will get 205.16.37.47. Okay. So this is the last address, which is your broadcast address. Okay. So now you know that 37.2, okay, dot 32, so the 32 until 47. Okay, so this is your this network lies within this. Okay, so 32 up to 39. So you have the 39 within this range. Okay, and this is the first address, and this is the last address. Okay, so and in between you can have the number of different IP addresses. Okay, so and basically this will call the network your network ID, network address, and this is what we call the broadcast address. Okay. So the number of addresses in the block can be found by using the formula 2 to the power of 32 minus n. Okay, so just now you have 28, so 2 to the power of 32 minus 28 minus by 28. Okay, so you get 2 to the power of 4. Okay, so 2 to the power of 4, 1. So you how many that you get here? 2 to the power of 4? 16. So you have 16 number of hosts. So if you can see here, 32 until 47, you get 16. Okay, so that is how it meant by the number of blocks that you can use is 16. Okay, so meaning that this is the number of hosts that you can use for this, which is the 16 block hosts. Okay. Okay, example here, for instance, a block of address, same values. Okay, so now find the number of address. Okay, before this, you are asked to find what is the first address, and the second one, you ask what is the last address, over here. Okay, and then now we wanted you to find what is the number of address. Okay, So the value of n is 28, which means that the number of address is 32 minus 28, which is 16. Okay, so this is the number of addresses that you can use. Okay, and then here it mentioned that the first address is blocked, okay, because normally not assigned to any device, and this is what we call the network address, right? So this is the network address, and then that represent the organization to the rest of the world. Okay, so here the first one is 192 and 205 16 37 32 is the network address. Cannot be used by the host. Okay? And each address in the block can be considered as a two-level hierarchy structure. The leftmost n bit prefix define the network, and the rightmost 32 n bits define the host. Okay, so that's already mentioned to you. Okay, and you can actually segregate your network into different numbers of users. For instance, over here you can have your network, okay, 17, 12, 14, 0/26. Okay, so if you want to divide it into two segment, okay, so this is considered one segment, this is another segment, so you will have the /27. Okay, how do you get this? I will show you in the cheat sheet later on. Okay, and also you will actually this one can also be again subdivided into two different segments. Okay, so with respect to that, you have the /28 for both of these. Okay, so how do we do this? I will show you later on. Okay, so with respect to the you need to know what is the IP range, okay, for the subnet 1, what is the IP range for subnet 2, and what is the IP range for subnet 3. Okay, so moving forward for the classful, okay, so we already identified that classful will be a wasteful of addresses. So we want to manage it much more efficiently. So we need to use what we call classless addressing. Okay, so the growth of the internet, okay, is bigger and bigger. Okay, we need some long-term solution which already here, which is using IPv6. Okay, but in between we have to find a short-term solution. Okay, so you need to use this what we call classless addressing. Okay, so this is why we use this classless addressing to represent it. Okay, right. Okay, so here you can see that variable length of block in classes addressing. Okay, so address bin and so forth. Okay, so this one I think. Okay, so it can be represent classless identification. What does it mean? I can't remember. You have the CIDR class CIDR. Can you please find out again what's the CIDR represent? Okay, so you have the fourth octet / by the prefix length as mentioned. Okay, so this is how you represent in a classless environment. Okay, so you have the 12, 24, 76 .8/8, 12, and 25. Okay. So with respect to that, we can identify, okay, what will be the numbers of the network and what's number of hosts. Okay? So the number of addresses that can be used for the host, okay, or the suffix over here is actually 32 minus by n. Okay? So set all suffix bits to 0. Okay? So anything that you have this turn to 0, okay, and anything that you have turn this to 1, all ones, okay, with the number of suffix, this will be the network address for your subnet. This would be the broadcast address for your subnet. Okay, so in between are the addresses, and this is the first address, and this is the last address. Okay, same thing that we already see just now. So it doesn't limit to class A, B, or C. It can be the full range lah. Okay, so you can have any suffix that you want to have. Okay, so for instance over here, okay, a classless address is given as 167.191.170.82/27. Okay, so we can find the above three pieces of information as follows. the number of address. Okay, so the three things that we can identify just now is that we will know what would be the first address. We will know what will be the last address simply by identifying what is the subnet, okay, which is current that we use over here is 27, right? So now with respect to that, we and then we also know what would be the number of hosts that it can contain. So say that now the 167.199.170.82/27. So if you change this to your binary number, okay, and since you know that 32 minus by 27, you will have 5, right? So basically, you are taking all these 5 to represent your suffix or your host. Okay. So if you have this example of address, okay, with 01010010, okay, and you change the last 5 bits over here to 0000, and this will become your the network address. Okay. So now your network address or the first address of your subnet will be .64. Okay. And the last would be when you change the 5 bit into 1111. Okay. So when you convert it, it's 95. So your address will be between .64 to .95. So that should be okay because you are looking for 82, right? So 64 to 95, in between you have the 82, meaning that this is within this addresses. Okay? And then the number of hosts that it can represent is actually 2 to the power of 5 just now, which is 32. Okay. And the usable now network of address that you can use is actually, as mentioned, minus by 2 is 30. Okay. Okay. So in cluster addressing, an address cannot define the block of address belongs to. For example, the address 230.424 and 56 can belong to many blocks. Some of them are shown below with the value of prefix associated with the block. So what does it mean here? It means that although you have the same address, okay, but if you use different subnetting, you will see that it belongs to different network. Okay? It doesn't have to be in the same network all the same time. Okay? So say that you use the subnetting of 16. Okay? So your block over here, okay, is 24. It can be between the 0.0 until 255.255.255. Okay, so this is the class B itself. Okay, so the network here, 28.24 will be between .8.0, .8.255. Okay, so that's the range. Okay, but if you use a prefix length of 20, okay, so your range, if you do the the process that I mentioned just now, the range is actually from 16.0 until 31.255. Okay, and if you go more, okay, for instance, up to the 31, so your range will be much smaller, okay, which is between 24.56 until 24.57. Okay, so your range will be much more smaller, meaning that the number is actually much smaller number of hosts that it can be represented. Okay, that's good for a small network or small organization. Okay, but you can see from here, if you use different subnetting, your network will actually be involved in different network segment. Okay, so this is that represent that the same IP addresses doesn't have to belong to the same range of network. Okay. So here they can actually represent the IP addresses. Okay, represent for different interface. Okay, so say that you have your PC, right? You have only one interface. Okay, so you need to have only one IP address. But if you look in depth, okay, for the current situation, your PC will have two different interfaces. One is the Ethernet and networking, and the other one is wireless, meaning that if you are connected through your LAN cable, and also you connected through your wireless cable, meaning that you have two different interface and two different IP addresses. Okay, so with respect to that, you need to have different IP addresses. So looking at this, you can see that for each devices, now you already have two for each devices. So if you have a lot of devices, so IPv4 doesn't or doesn't get this. Okay? And then in the router itself, okay, so you need to have what we call mapping, okay, between the network address and also the interface number. Okay, so you have in your network router, okay, where you identify your network address with your interface address. Okay, so you have the forwarding table. Okay, and in ISP, as requested, a block of 100,000 address. Okay, so now you need to support 1,000 addresses. Your host. Okay, so now the host is 1,000. And since 1,000 is not the power of 2, but 1,024 addresses are granted. So the prefix here is that you need to use the 22 lah. Okay. 32 minus log of 1024, okay, which is 22, meaning that you have to use the mask of 22. Okay. So from this decimal, you can see that 32 91460, which is divisible by 1024. Okay, so this is for your, if you wanted to have 1,000. Okay, so another example, if an organization has the /24 and the organization needs to have 30 subblock in address to use its 3 subnet, one subblock of 10 addresses, one subblock is 16 addresses, and one subblock of 120 addresses, design the subblock. Okay, so the first thing that you need to do is that you need to count the total number of addresses so that you can identify it later on what would be the subnet. Okay, right now you need to cover 10 plus 16 plus 120. Okay, so you have 190, right? Okay, so you need to address this 190. So assume you're using a class 4 addressing. You have what we call VLSM, variable length subnet mask. It's used for reducing the IP addresses. Okay, so this is a new term that you encounter for today. This is called variable length subnet mask, okay, that can reduce the IP address wastage. Okay, so again, coming back to what I've already mentioned, the first thing that you need to identify what is the total addresses. So you actually wanted to support 190 addresses. Okay, so with respect to that, okay, so to the power of 2, the closest that you can have is 256. Okay, so this is the address that you actually need. Okay, so here with respect to that, okay, you can see that the 24 can be used to support this 256 altogether, but it doesn't is in the whole same subnet. Okay, but you need to divide it into multiple subnet later on. Right, so the last address, okay, the first address is .0, 74.0, and the last address is 74.255. Okay, and to satisfy this third requirement, we assign address to the subblock starting the largest and ending with the smallest one. Okay, so the next one is that after you know that you have to support 120, you need to support 60, okay, and also 10. Then you have to know what would be this nearest number. Okay, the one that closest to 120 is 128, right? Okay, and for 60 is 64, and for 10 it should be 16. Okay, so you need to identify this 128, 64, and 16 that can be used for the rest of the segment. Okay. So with respect to that, okay, you need to find what's the number of address of the largest subblock, which is the 120 addresses, okay, which is not in the power of 2. So as mentioned, you need to have the 128 address. Okay, So with 1 to 8, 32 minus the log of 1 to 8, we need to use the subnet of 25. Okay, so the first address for this block will be 124.74.0/25. Okay, and the last address will be 124.74.127. Okay, so /25. Okay, and the number for the second largest block is 60. Okay, but again, it's not in the power of 2, so you have to go to 64 addresses. Okay, so with respect to that, you continue from here. Okay, since the last one is 1 to 7, you have to go to 1 to 8. Okay, /26 until 74.191/26. How do you get this? Basically, the 26 you can get it from here. The first address, you change the all the suffix into 0. Then you will tend to have this, and if you change the suffix to all ones, you get this. Okay? So you can do that on your own. And last but not least, okay, so you also need to cover the 10 addresses. Okay? So we need to allocate 16 rather than 10. So 32 log of 16, okay, is 28. So it's /28. So the first address, it's actually continuous from here. After 191, you use 192/28, and the last address is 207/28. Okay, so if we add all the addresses in the previous subblock, the result is 208 address, which means 48 addresses are left in the reserve, and the first address in the range is 74.208, and the last address is 74.255. We don't know about the prefix yet left, figure shows, and so forth. Okay, so basically, although you have already rearranged this, so there are still some IP addresses that being left out. Okay, so because you have the 208 over here, okay, you have how do you get the 48? You minus by 255. Okay, 255 minus by 208, you get the 48. Okay, so that's the leftover addresses. Right? So this is how it looks like. Okay, so you have the 28, N25, and then you have the N26, 64, and the last of 38 with 16, and unused is 48. So the whole 256 addresses, okay, that being used the subnetting can be divided as this. Okay? And here you can see that the figure 1 shows how 4 small blocks of addresses are assigned to 4 organizations by an ISP. And the ISP combines these 4 blocks into one single block and advertise the larger block for the rest of the world. And any packet destined for this larger block should be sent to this ISP. It is responsible ISP to forward this and so forth. So basically, when you have or when you subscribe to any ISP, for instance, right now you subscribe to TM. Okay? So perhaps you are part of the whole subnets of TM. So they have a bigger chunk of addresses, perhaps on IP address that have bigger range, okay? And you are part of it. So meaning that you can subdivide, as we mentioned just now. Okay, so that you'll be able to use with whatever the IP address that you have within the TM or that specific ISP. Okay, so if you have to move to different ISP, you'll be given a different IP addresses. Okay, so here you can see that it's being given to you some addresses. Okay, block 1, okay, block 2, 3, and 4. Okay, so this can be your whole organization that subscribe to that specific ISP. ISP stands for Internet Service Provider. Okay. I think that will be all on the IP addresses. Okay, but later on, I will also show you some what they call cheats, IP cheat sheet, okay, or subnet cheat sheet. Okay. So before that, we just want to continue with the slides. Okay. So basically, okay, if you wanted to get involved with the internet working, so you need to have all the IP addresses that are being seen by all other users. Okay. But due to the IP addresses of that actually exhausted or not enough for each and every user, So what we can do is that we can put all our organization in one called private addresses, okay? And then we have a router that can connect to the internet. Okay? So going outside, you have the uh, the normal, or what you call normal. This is a private, this is public. Okay? So the public address, okay? And this will be your private address. Okay? So it is not matching, but whereas with the use of router, you can actually send whatever the packet from the private network to your public network itself. Okay, so here you use 172 network, okay, in your private, and then the public is 200 network. Okay, and when you wanted to send packet from your private to your public network, okay, so you need to actually put some information onto your header of your packet, okay, saying that, okay, so the source is 127, this data information, okay, the source is this specific private address, okay, and then the router will actually change it because the router has the mapping, okay, what we call the network address translator between the source, between the public and the private network. Okay, so at the router, you will change the addresses, okay, from the private to a public one, okay, and then go through the whole the link till you reach the receiver. And when the receiver wanted to reply, okay, so you will have the destination using this, okay, but basically you will know that the actual destination is your private network IP address. Yes, so you have this what we call network address translator table that actually represent between the public and the private. Okay, so external or the private. Okay, so now you have the net table that can represent. If you wanted to have this, okay, so you have to go through this external, then come back through. When you come from the external, you have to change it to private. Okay, so this is how it can be defined in a network address translator. Okay, right. So that is network address translator. Okay, then for the TCP/IP protocol suite, as mentioned, currently we are on the network layer. So the big part of the network layer is IPv4. Okay, so which manage the addresses. Okay. Other than that, you have also the ARP and RARP. You have also what we call IGMP and ICMP. Okay. This is for control protocol. This is for your multicast protocol management. Right. The rest is under different layer. Okay. So the one that we are having here is on the network layer. Okay. But we also have other protocol that help to manage the IPv4. Right. So for the transport layer, you can actually see that on the information within the IPv4, it can also comes from other types of layers. Yeah, it can be from TCP, UDP, or also for the other network layer. Okay, so that is why here you can say that on your information packet, okay, you will also need you will see that you have the UDP, TCP, or even the other management and for the routing protocol information being used on top of your network layer IPv4. Okay, so for addresses, okay, as we already seen, is that we need to match between your logical address and also your physical address. Okay, so the physical address over here represents the MAC address. Okay, so here you have the MAC address, and here you have the IP address. Right? And so you need to map this, and the one that we already see is using what we call ARP, address resolution protocol. Okay, so in one of our experiment, we'll see that when you are connected to a network, okay, so you can see that at the beginning, you don't know where to route this packet. So this ARP information or this ARP protocol, when you already connected, it will send messages, kind of a broadcast to all the interface within that specific network, asking, okay, so what is your IP, what is your MAC address? Okay, so you will try to actually match, or you will try to identify the IP address with the MAC. Or for instance, within the network, you already have the IP and you are looking for this IP. So you will ask the whole network, okay, are you this IP address? Okay, so if yes, then you will actually define what is the MAC address of it, right? So you have to request when you enter the network, okay? So you will have to request to the whole system, okay, looking for a physical address of say that is 141, okay? And then you will reply here, and you can see that the ARP is a broadcast, okay? But when it replies say that is the IP address, it will say that okay, say here this is my IP and this is my MAC address. Okay, so you reply in a unicast mode. So ARP request is broadcast and the reply is unicast. Okay. Okay, other than that, you have the ARP, BOOTP, and DHCP. Okay. So you can see that other than the ARP, you need to have different addresses. And for instance, you can need to have the DHCP. Okay. So DHCP is a dynamic addressing, whereby when you enter any network, you'll be given an IP address. Okay? So rather than have to define it static as a static address, okay? DHCP can actually use a dynamic address allocation. Okay? Same goes when you come to enter the same network the next time after you have logged out of, you have gone for a while, okay, and you come back and suddenly you see that you be given the same IP address because they already mapped the IP address with your MAC address that it assign it dynamically. Okay? So DHCP provides static and dynamic address allocation that can be manual or automatic. Okay? So automatic is where you make it a dynamic one, okay? Or static where you actually can give it or you can fix the IP address to some specific network. Okay? Right, then for error control, okay, we use what we call ICMP, Internet Control Message Protocol. Okay, this is for error reporting and error correction in the network layer. Okay, so the IP protocol also lacks of mechanism for host and management queries. So you need to add additional protocol, okay, ICMP, which is to compensate for the above two deficiency. It is a companion to the IP protocol. Okay? So what does ICMP do is actually creating error reporting and query messages. So it's just to exchange messages. Okay? So error reporting message report the problem that a router, a host destination may encounter when it processes an IP packet, and it will give the information to perhaps to the rest of the network. Okay? And the query message which occur in pairs help a host and or a network manage to get specific information from a router to or another host. Okay? So these are the things that you can actually use. Okay? The query message, basically you want to exchange the information on the router, or perhaps you want to report something. Okay? Right, so these are few error reporting message that come with the ICMP. We have the destination unreachable, source quench, time exceeded, parameter problem, and redirection. Okay, so these are the things. I don't suppose you can remember this. Okay? So ICMP always report error message to the original source. Okay? An ICMP packet is being inserted into your IP data structure, okay? And then sends as an IP packet. Okay? Whereas IGMP, okay, is for management protocol. Okay? IGMP is the Internet Group Management Protocol. Then what are necessary but not sufficient. Protocol need for this one is for multicasting. Okay, so you need to have this IDMP. What is multicasting? Basically, is a subset of broadcast. Okay? Multicasting, as mentioned, is a selective group of user that you send this message to this selective group of user. Okay. So for multicasting in the internet, we need this router to be able to route multicast packets. Okay? And IDMP is protocol that manages this group of membership. Okay? So you need to somehow first gather the information of the users, group of users, okay? And then you can send to that specific user. The IDMP protocol gives the multicast router information about the membership status and connected to the network. Okay? And the IDMP is a group management protocol. It helps to multicast router create and update the list of loyal members related to each router interface. Okay? So this is how it manages the group of selected members. Okay? Compared to broadcast where you have to send to everyone. Okay, and last but not least, okay, I think this would be the IPv6 would be the last thing that we would like to cover for today. Okay? Compared to IPv4, which you have 32 bits of address, okay, for IPv6 we have 128 bits long. Okay? So it's considered as very big usage of addresses. Okay? And since it is too big, okay, so rather than be represented as decimal, it's being used as hexadecimal, and it's actually being divided into eight actually. 1, 2, 3, 4, 5, 6, 7, 8 components, and each of these is being represented by a binary, right? Okay, 60 bytes, 32 hexadecimal digit. Okay, so 32. Okay, so you have this you have two bytes altogether. Okay, 2 bytes. Okay, so that you have 32 hexadecimal. Okay, so here you have 16 bits altogether over here for one component, and it's being separated by this dotted conversion. Okay, so your binary bit will be the whole zeros and one, and then it can be also defined as in hexadecimal. Okay, so the first group would be having the 16 bits, okay, or 2 bytes, okay, then dotted by and so forth. Okay, so here you can see that it has a long addresses compared to the IP addresses. Okay, but sometimes you can actually simplify it. For instance, if you have these zeros, okay, so the zeros can be represented in much more simplest way. Okay, so for instance, if you have this number, okay, so you can make it smaller or make it shorter by having something like this. Okay, so instead of FDEC 0007, so you can just represent this 74. This 0 can be represented as 0. This 0 can be represented as 0. This 0 can be represented as 0. But this 0 cannot be suppressed, so you have to maintain B0FF. This can be represented as single bit 0 and then FFF0. That needs to be maintained. Okay. And another thing that you can see that if you have a gap over here, okay, so you can just leave it out by having 2 columns. Okay, with respect to this. Okay. So when you have to do this, and you have 2 zeros in between this one you cannot suppress. Okay, because how do you, the convention of this is that you can count. You have 1, 2, 3, 4, 5. 5 out of 10, meaning that within this you have this 3 segment. Okay, so that is why you cannot like making the simplified by having this also being suppressed as a double quadrant. Okay, so you cannot do that. Okay, so you can just have, if you have a gap between this, so you can only have one of it to be suppressed. Okay. So here it says, for example, expand the address this to its original. Okay, so here if you have this, okay, meaning that you can start with this 0, meaning that you can have that this is all for zeros. Okay, the 15 is equals 0015. Then we wait for this. 1 is 0001 over here. The 12 is 0012, and the 1213 is over here. And then between these, there's zeros. Okay, so you count this 1, 2, 3, 4, 5. So you have 5 what they call hexadecimal block. Okay, minus by 8, meaning that between this you have 3. Okay, so that is why you need to have 3 additional zeros in between, right? So that is how you can get back from the address to these original addresses. Okay? And in IPv6, okay, you will also have this control protocol, but it's now it's the ICMP version 6. Okay, so this is for the IPv6 version 6. Okay, so with respect to that, okay, so this is our end of our discussion for today. So we already seen the class 4 classes. Okay, then we also see on the masking. Okay, then we have also seen how you can translate between private to public addresses in a network address translator. Then you need to also map your address to your local address or your IP address to your MAC address itself that is given to either static or dynamically. Okay? And then you have the ICMP, IDMP. ICMP is for you to manage error and also for sending messages. Okay? Whereas for IDMP is for multicast purpose of management. Okay? And then we also seen the IPv6 address and structure. Okay. So with that, I would like to open to any question. If there's any from the floor. Any question? Okay. Okay, there's question for Zaman. Sir, is our marks there a yellow row that does what does that represent? Okay, so basically the yellow one means that you guys use or for the quizzes you enter it on your own, right? Okay, so you put your student ID. Okay, but then I have also my list that I extracted from the MMU system. So the yellow one basically is not in my list. So I just highlight that so that I know that perhaps if I have a new list, I will actually update it. Okay? Nicholas, your mic is on. I think it's already solved the problem. When will the mark test one be released? Basically, I've already released the mark, okay, Wong Yang Hong, and also the solution I've already released. Okay. Any other question? Nothing. Tutorial 3 to 5 today. Yes, we have. Yes, mark for test. Oh, test 1. Sorry, test 1 haven't. Sorry, test 1 I have released. The one that I've released, quiz 1 and quiz 2. Sorry. When will the mark test 1 will be released? I'm trying to catch up with the task by having it today. Not. I'm trying to catch with respect to the time that I have. I will release it as soon as possible. Tutorial 3 to 5 today is basically physical. Where's the mark? It should be in for quiz 1 and quiz 2 is in the Google Classroom. Anything else? If not, Do you have any other question? If not, I wanted to enter the quiz mode. You guys ready? Yeah, ready? Yeah. Right. So this is the link. Perhaps somebody says that. Please share also on the Google Classroom. Okay, so I share it in Google Classroom. You know, start there. Wait for me. Uh, right. So you have 10 minutes for now. So 11:43 will end at 11:53. Yeah. Okay. So you can start answer the quiz. If we already have one, then submitted. And 2% already submitted. What is it? Yes. Oh. Okay, we already have 58 submission. Another 2 more minutes. Our two distinct girl over here also haven't finished. 11:52. 1 more minute. 1 more minute. I give you 1 extra minute until 11:54. So this is your current result. Median is 9, average is 8.67. Range between 6 to 10 points. So there's somebody got score 6, but actually already passed up. Few people got 10. Congratulations. 96. Another 20. Sir. Few more. Dah sampai belum? Kawan-kawan. Kawan-kawan fizikal dah sampai belum? Dah. Dah. Dapat berapa? Oh, tak dapat result? Okay. Right? Everyone has submitted? 1 to 4, 1 to 5. 1 to 8, right? Why there's so many? Right? It should be 1 and 2. Somebody submit twice, right? Right? So, anybody haven't finished? Everyone has submitted, right? Yes, you can leave after submit. Can we see the summary of section? And I have attendance link. Thank you for those who give share the attendance link again. Right. Okay, so I close this quiz. 1:30. I close this quiz. Stop. Accept responding. Okay. Then how do I the setting? Question. But yeah. Set question. Setting. Responses. Individual. Okay. Yes, so I've already released the result. Okay. I think with that, that's the end for today's session. Thank you very much for your attendance. Those who have tutorial with me on Monday, so I just want to inform you that we have next week 2 sessions. One would be in the morning and the other one would be at night, which would be what they call it, it's an online one. Okay, online mode. Okay, the one on the morning is the physical, right? But if you can finish all, we don't have to do that for the online one. Okay. So, anything before we go? Thank you. All right. Thank you very much, and I'll see you